Hello everyone. The title of this video is Finding Domain and Range from Graphs. So every example I'm going to be doing in this video is taken directly from a free online textbook at openstax.org, and I'm in their Algebra and Trigonometry text, section 3.2, titled Domain and Range, and I'm under the heading Finding Domain and Range from Graphs. Alright, so everything I'm doing in this video is either going to be an example taken directly from the reading here, or one of the try it problems throughout the reading, or one of the exercises at the end of the section related to this particular objective. Alright, so you see I just got these written out. Again, finding the domain and the range from graphs. Remember just recall a couple things, right? Some definitions. Remember the domain is the set of all the input values, right? There are inputs and outputs in a function, right? Or a relation. This is just the set of all inputs, which for our graphs will be the x coordinates, right? The set of all values of x used in points of the graph. And the range is the set of all outputs, which for our purposes here, right, when we're looking at graphs on the xy plane, this will be the set of all the y coordinates that are used in points of a graph. Right, so if you keep that in mind, this should be relatively simple. So the first example I'm going to do is actually example 6, taken directly from the reading. You're seeing this here, right? And they talk about domain and range. I'm assuming you're reading this stuff. So here's example 6 from the reading, right? Find the domain and range from a graph. Find the domain and range of the function f whose graph is shown in this figure. Okay. So I'm going to draw a rough sketch of this on my paper. All right, and what I'm noticing here though, before I look at my sketch, I mean, this is obviously going to be a better picture than what I'm going to draw. I'm noticing that, the graph going from left to right starts at this point here. Now notice that is an open point, meaning that it's missing. It's not there. So that is not a point of the graph, but everything after it is on the graph of f here. And then at the end, you see this solid point, this filled in point, that actually belongs to the graph, right? So open points don't belong, filled in points and solid points do. So for the domain, you look at the x-axis from left to right, you always go low numbers to high numbers. Look at the x-axis from left to right and think about what x values are actually part of the points, or actually used as x coordinates for points on this graph of f. So we have nothing here, nothing here, nothing here, and then at -3 it starts, but it really isn't there though. Pardon me. So there's no point with an x coordinate of -3, but the rest of the points have x coordinates, from -3 all the way up to 1, right? You see, if you follow the flow of graph of f here, the x coordinates go from -3 to 1, not including -3, right? There's no point there, but including 1, right? You see the solid point down here is that, has an x coordinate of 1 and a y coordinate of -4, so the x coordinate of 1 is used. And then after 1, x values greater than 1 are not used. There's no graph anymore. Right, so back on my paper, I got this written out here. And for the domain, you're looking this way on the x-axis, right? What x-axis values are used. So the domain here, you can describe it in words. It's all the real numbers, all real numbers between -3 and 1. Again, I'm looking on the x-axis, not including -3, but including 1. Okay, so you can describe the domain in words. You can use what's called set builder notation. So remember, domain is x values. Right, so I write the little set braces, and I say, the domain is, all the x coordinates such that x is between -3 and 1. Right, so I write a little compound inequality here. Not including -3, but including 1. Right, so a little half equal sign under that inequality symbol. Okay. Because again, -3 is not used as an x-coordinate, but 1 is, right? This is the point 1, -4. Or, you can use interval notation. Remember how to, again, I've put up videos before where I've used interval notation, using interval notation. You can look those up or watch other people's videos or do the reading or whatever. I'm assuming you know interval notation. All the numbers from -3 to 1 would look like this, right? From -3 to 1, not including -3, so parentheses on -3, but including 1, right? 1 is actually part of the domain, so you put the brackets, the rectangular bracket on 1. So there's 3 different ways to describe the domain of this function. And they're all equally valid. Describing it in words, what x coordinates are used, describing in this set builder notation, and describing it with interval notation. All 3 of these are the same set of numbers. They're describing the same x coordinates, right? All the inputs for the function f. All right, now for the range, you're thinking about the y-axis. Right, so I'll go back to the actual picture from example 6. Right? Now remember, you're going low to high, right? You're always going low numbers to high numbers when describing sets of numbers. So I'm looking at the y-axis, the y-coordinates for the range, right? The outputs. So you go from the bottom up, right? You go up the y-axis. That's how, that's low numbers to high numbers. And see what y-coordinates are actually, used in this graph of f. Well, the lowest y-coordinate that's used is -4. Right? You see this point here. Looks like this point over here also has -4 as a y-coordinate. Nothing below -4. All right. So the lowest y-coordinate that's actually, the y-coordinate of a point on this graph, at least one point, is -4. And then it looks like every value above -4 is used in a few points, right? Up until 0, right? The highest this graph gets is the y value of 0. Now, this open point doesn't have a y-coordinate of 0, but this point does, right? It looks like there's a point of this graph that actually touches the origin. So you might think, oh, 0 is not included, but because of this point, 0 is included as a y-coordinate. And then every y value above 0 is not used. There's no graph up here. All right. All right, so back on my drawing, right, for the range, right, when you're talking about the range from a graph, you're looking from bottom to top. You're looking up the y-axis, right? And it's going from -4 So again, the range here. Now you can describe it in 3 different ways. In words, set builder notation, or interval notation. So it's all the numbers, from negative on the y-axis are used as y coordinates here, outputs from -4 up to 0, including -4 and 0. So I'd say it's all real numbers from -4 to 0 inclusive. That just means -4 and 0 are included in the set. They are outputs. They are y coordinates in this graph of f. Alright, so there's a description in words. Now I can use set builder notation as well. Now be careful. Now I used values of x for the domain, right? Domain was x coordinates. The range is y coordinates. So I'm going to use the variable y in the set builder notation for the range. I hope that makes sense. And it's all y values from -4 to 0. And again, notice I'm using y now, right? Inclusive, right? So little half equal signs under both of those, right? So every number from -4 to 0, including -4 and 0, are outputs in this function. And then what's interval notation for -4 to 0? Right, that's -4 comma 0, including -4 and including 0. So brackets on both of those. So, yeah. Again, all 3 of these are the same set of numbers. They're all equally valid ways of describing the range of this function f that was drawn for us. Great. And that's all I'm doing for this video. I've got a bunch of examples, but this is all I'm doing. Where's the graph located? Look at all the points on the graph. Look for open points, filled in points, know what's included, know what's not. For the domain, you're looking along the x-axis from left to right and just stating what x coordinates are actually part of this graph, actually used in the graph. And then for the range, you're looking up the y-axis, right, going from bottom up, low numbers to high numbers, and seeing what y values are actually used as y coordinates, as outputs in the graph. It's really that simple. And then you either, now most online homework systems I've noticed will ask you to put things in interval notation, but I'm telling you right now, if you were doing things by hand and no one asked you for any specific notation, you could describe these sets of numbers in words, in set builder notation, or in interval notation, and all would be equally valid. Great. Okay, so I'll probably do this on a separate page because I took up a lot of space here, but example 2. I'm asking myself to do try it problem number 6 from the reading. Alright, so scrolling down a little bit, now there's example 7, I'll leave some stuff to you. Here's try it number 6. So given figure 12 here, right, the horizontal axis is years, and the vertical axis represents millions of people, and it's a graph on world population increase. Looks like from 1950 to 2000 here. And it just says identify the domain and range using interval notation. And that's it. Alright, so again, domain is going to be values along the horizontal axis, right? The horizontal axis usually, typically represents the input values of a function. And the range will be representing values from the vertical axis, right? The vertical axis usually represents output values for a function. So looking at the graph here, these actual points that show up, looks like, my lowest horizontal value, the lowest year, the lowest input is at 1950. and it continues on. There's no breaks, there's no holes, there's no gaps, all the way up until 2000. Alright, oops, sorry, you probably can't see my cursor. I'm moving along, moving along, moving along. The lowest horizontal value, the lowest input year is 1950. The highest input year, it looks like 2000. And everything in between is used in some point. So I won't even draw this. I'm just going to write this up then. So the domain in interval notation, right, that's all they asked me for, is from 1950 up to the year 2000, right, always low to high, left to right. And it looked like 1950 was included, right, there wasn't an open point there, so bracket on 1950, and same thing for 2000, right, there was no open point at the end there, like in example 1 with the empty point. So bracket on both ends, so every year from 1950 to 2000, including 1950 and 2000. Alright, so that's the domain in interval notation. Now for the range, we're looking at these, millions of people, the vertical axis, and going low to high, going from the bottom up. Now the lowest output, the lowest, millions of people value here, looks just below 50. So, and they're having you to just kind of eyeball these things, not perfect. So this looks like maybe 48. I'll say 48. Why not? And then the highest, going up, 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 every single output, every single one of these values on the vertical axis is used up until the, the highest point. The highest of these values looks like 90. So I'll say from 48 to 90. Now let's see how they eyeball. Oh, well, it's a try problem. All right, so I'll just say from 48 to 90, including, right? There's no open points here. So the range for that particular problem, let's say, goes from 48 to 90 on the vertical axis, and everything in between, and including 48 and including 90. Okay, and that's all. All right, we were only asked to state the domain and the range in interval notation. So again, looking along the horizontal axis from left to right, and looking at the vertical axis from bottom to top, right, bottom up. Great. All right, so my next example is just another taken from the text, another picture from the text. Got 4 of them on this page because they're all pretty similar. I'm just going to be showing you some graphs from some exercises. All right, so example 3 is I'm going down to exercise 28 in the text. All right, so you keep scrolling down, go through the section, all the reading and junk, right? So down to the exercises, here we are, section exercises. And 28 asks us to do this, it says in the graphical part, write the domain and range of each function using interval notation. Okay. So I'll leave 27, the odd ones to you. You can actually see the solutions to the odd ones if you click on the links, but I'll leave those to you. All right, so 28. All right, I'm looking at this right now. Again, the domain, you look at the, there's just this one little segment where on the left end of the segment, the point is there, it's filled in, it actually belongs. And on the right end of the segment, there's no point. It's an empty point that's not actually there. So going left to right for the domain, it looks like 4 is the lowest x value used. And it looks like every value up until 8 is used, but then 8 is not because there's an empty point. So the domain looks like it's from 4 to 8, including 4, but not including 8. All right, so I'm going to write that out on paper. All right, so for that particular one, the domain is all the values from 4 to 8, everything in between, including 4, right? Bracket on 4. 4 was used in that solid point as an x-coordinate, but not including 8, right? There was no solid point with 8 as an x-coordinate. Now you could also, if you know, there's interval notation. You could also write it out in words if you want, or in that set builder notation. You know, it's all values of x that are between, 4 and 8, including 4 but not 8, right? And you can write it that way as well. But this is what they wanted, though, right? This is what they wanted, the interval notation. All right, and then for the range, let's go back to the picture. And now I'm looking from, on the y-axis, I'm looking bottom up, I'm looking at outputs. Now the lowest the graph goes is at a y value of 2, but that's not there. There are no solid points. There are no points on this graph that have a y coordinate of 2. All right, so 2 is not in the range. But then it looks like every y value above 2 is used, right? There's some solid points here with those y coordinates from 2 all the way up to 8. And 8 does have a solid point, right? 8 is a y coordinate for this left endpoint of this segment. So for the range, it's from 2 to 8, not including 2, but including 8. Right, going low to high like that. So the range is every y value from 2 to 8. Right, so 2 comma 8, not including 2, right? 2 was not a y coordinate for any of those points. So parentheses on 2. But including 8, right? So bracket on 8. Because 8 was a y coordinate for that top point. Now if you want to as well, right, you can write this in set builder notation. Right now, don't forget it's range values, so y's, right? So it's all the values of y that are between 2 and 8, not including 2, but including 8, right? It's a little half equal sign under that second inequality symbol, right? So you can write that as well. That's equally valid. But they did want it in interval notation, right? So this is what I would answer if that's what they asked for, right? This 2 to 8 with the parentheses on 2, bracket on 8. Right? And yeah, it really is this simple. I feel this is simple in my opinion, right? So hopefully with some more practice, if you don't feel it simple, hopefully with some more practice here, more examples, it'll be easier. It's usually how things go. Alright, so the next one I'm doing exercise 30. And again, we're asked to state the domain and the range, so I'll just write those out right now. Domain equals range equals. And let's look at exercise 30. Right, so there's 29 here. Here's 30. Alright, so there's the graph we're looking at. Now notice there's no arrows or anything. It's just a dot to a dot. Alright, dot to a dot. Now if there were arrows, right, like the arrowheads here, that means it's going that way forever, but that's not happening here. Alright. So it's just from one point to another, and they're starting and stopping somewhere. Alright, so for the domain, right, I'm looking again at I'm going along the x-axis from left to right. And none of these x coordinates are used where my cursor's at now, all the way up to 2, and then 2 is used. 2 is an x coordinate and input for this point, this solid point on the left of the graph. And then all these points from 2 up to 6, I know they didn't label 6, but this is 6 here based on the other units. Every x coordinate, every x value from 2 to 6 is used in some point here, right? This is a continuous piece of graph. There's no holes or gaps in it. So everything from 2 to 6 is used, and also 6, right? There's a solid point at the right end. 6 is an x coordinate. So from 2 to 6, including 2, and including 6. That's the domain. So from 2 to 6, right? 2 comma 6, including 2, right? Bracket on 2, including 6, bracket on 6. You get what's called a closed interval. Now you could also write this in set builder notation if they asked. It's all values of x, all values on the x-axis, such that x is between 2 and 6, including 2, including 6, right? The little less than or equal to symbols. Alright, but they only wanted the interval notation though. Alright, so I would answer that. And then for the range, I'm looking at y values, right? Outputs, going from bottom up, right? Going from the bottom up on the vertical axis. Now, going from the bottom up here, the lowest y coordinate that's actually, the y coordinate of a point, there's a solid point here, is -6. So from -6 and then keep moving up, all these y coordinates are used in some points in these graphs, right? In this graph. So from -6 all the way up to -2, right? And -2 is a y coordinate for this point and this point. There's a solid. And then above -2, right? Those y values aren't in the graph. Right? There are no points above that. So from -6 up to -2, including -6 and including -2. Right? That's the range. So from -6, comma, to -2 and all the values in between, including -6, right? Bracket on -6, including -2, bracket on -2. And there you go. And again, you can put this in set builder notation if you wish. Right, it's all the y coordinates, right? Don't forget, it's y coordinates, it's range, it's outputs, right? Such that y is between -6 and -2, including both of them. Right? But they wanted just this, right? They wanted just the interval notations for the domain and range. All right, great. All right, example 5. I'm going to be doing the next even exercise, exercise 32. Scrolling down again, you can do 31. All right, 32, again, there are no arrows on this graph. All right, it starts at this point. There's a bunch of points, reaches the highest point here, and then comes down. Sorry, the cursor's not there. Here's the cursor. So it starts at this point, and you got all these points, reaches the highest point here at like 0 for x, 4 for y, and then comes down, down, and then there's an open point at the end, right? So it stops here, but there's not actually a point there. All right, and no arrows, right? So it's not going off in any direction forever. All right, so first, domain. All right, again, domain, I'm looking along the x-axis, right? What x values are used in the points on this graph. And I'm going left to right, low to high. So going left to right on the x-axis, the first x coordinate that is actually used is -3, and it's actually used. There's a point there with an x coordinate of -3. And then all the x values from -3 up to 2 are used, right, in all these points here. But then 2 itself is not an x coordinate for points on this graph, right? That is a missing point. And there are no other points of the graph on, x equals 2. So from -3 to 2, -3 is included, 2 is not. Right, that's the domain. So the domain equals, right, every value of x from -3 to 2. -3 is included, so bracket, 2 is not. Right, 2 is not in the domain. There's no point with an x coordinate of 2, so parentheses on that. And if you were doing set builder notation, right, it's all values of x such that x is between -3 and 2, including -3 but not 2. Great, and now we're going to do the range. And for the range, right, that's the set of outputs, the y coordinates, right? So I'm looking along the vertical axis, the y axis, right, from the bottom up. low to high. So going from the bottom up, negative 5 is the lowest y coordinate being used here, and it's actually used, right? That is a solid point that has a y coordinate of negative 5. And then all the y values from negative 5, all the way up to 4 are used in some point in this curve. So you're like, oh, what about 0, right? That's not a y coordinate for this open point. Yeah, it's not a y coordinate for that open point, but 0 is a y coordinate for this point over here at like negative 2. Right? So 0 is in the range, and it's all the way up to 4. All right? And then above 4, now 4, there's a solid point there, right? It's filled in, no holes. So 4 is the y coordinate for this point up here. 4 is in the range. And then anything above 4 is not in any points at all. Not a y coordinate for any point at all. So the range is from negative 5 up to 4, including negative 5 and including 4. Right. So back here, all the y coordinates, all the y values from negative 5 up to 4. Right, so negative 5 comma 4. Including negative 5, right, bracket, including 4, bracket. And once again, if you wish, you could write it in set builder notation. Just remember these are y coordinates, right? So it's all values of y, such that y is between negative 5 and positive 4, and including both, right? Little half equal signs under each of those. Right? But they wanted, right? They wanted just these, right? Just the interval notation for the domain and range. Okay, great. All right, next example. 6, I'm doing exercise 34, right? The next even one. So here's 33, here's 34. Here's the first instance we've seen with an arrowhead at one end. This arrowhead means going in this direction forever. And that's kind of moving upward very slowly, but it is moving upward. So going up, 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 up forever. So there is no, that means there's no highest y value. Also, there's no largest x value, right, if it's going this way forever. All right, so looking at this, right, now there's no arrow on this left end, right? It starts at a solid point and then moves to the right, up, up forever, up, 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 up. All right, so for the domain, right, you're looking along the x-axis from left to right. And the first x value I'm noticing that has anything to do with this graph at all is at negative 4. Right? The x coordinate, and that actually is the x coordinate for this point, right? It's filled in, it's solid. So negative 4, and then every value above negative 4 forever is in a point on this graph, right? Is the x 1 is the x coordinate for this point. 2 is the x coordinate for this point. Pi, 3.14-ish, is the x coordinate for this point. 6, I know there's no graph there, but the arrow implies that the graph continues on. So 6 is an x coordinate for a point on this graph. Even though you can't see it, it's implied to be there by the arrowhead. I hope that's clear. So I could go out to 1,000,000 for x, all the way to 1,000,000. And the arrowhead implies that, even 1,000,000 is an x coordinate for a point on this graph. 1,000,000,000, a trillion, a quadrillion, a googolplex, any value to the right of negative 4 on the x-axis. So we're going from negative 4 to infinity, we would say. All right, so the interval notation for this, going back here, I'd say the domain, right, all the x values used as x coordinates here, is the set of numbers on the x-axis from negative 4, comma, to infinity, right? Because there is no largest x coordinate. Now you always put parentheses on infinities, right? Infinity is not a number. It's an idea. It's a concept. So it can't be included in the set. So always parentheses on infinities. And then we saw, negative 4 was an x coordinate for that one solid point. So I put brackets on that. Now, if I were doing, set builder notation for this, I'd say it was, the domain was all values of x such that x was greater than or equal to -4, and that's it. Right? There is no highest x value. Right? But they just wanted this, right? This domain in interval notation. But the set builder notation is equally valid, or you could describe it in words if you want all the real numbers greater than or equal to -4. Same thing. All right, and then next is the range. So again, I'm looking at what y values are used as y coordinates, as outputs in this function. And I'm looking at it from bottom up, all right, bottom up. So if I go bottom up on the y-axis, the first y value that has anything to do with this graph is -2. Right. This y value of -2 is actually the y coordinate of this solid point here. So -2 is in the range, and then every y value above it is a y coordinate of some point on this graph. Right? -1 is the y coordinate of this point here, where my cursor is. 0 is the y coordinate of this point. 1 is the y coordinate of this point. 2 is the y coordinate of this point. 3 is the y coordinate of this point. Now again, the arrow implies that this graph is going up, 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 forever. So even though you can't see it, 4 on the y-axis, 4 is the y coordinate of some point out here, right? If I follow the arrow, push the arrow onward, you would find a point with a y coordinate of 4. Same thing for 5 and 6 and 7. It might be way out here, but you'd find one if you follow the arrow. So every y value from -2 and up is a y coordinate of some point on this graph. All right, so the range is every y value from -2 and up. All right, so because there's no highest y value, y coordinate, it's going to infinity again, right? Positive infinity. And you always cap infinities with parentheses. Always. And -2 was the y coordinate of a point, right? That one solid point that we saw. So bracket on that. And that's all they wanted. But if you were to put this in set builder notation, it would be, the range of this function is all the y coordinates, all the y values, such that y is greater than or equal to -2. And that's it, right? There's no highest value. So all the values greater than -2 or equal to -2 itself. And great. And again, all they wanted was the interval notation, though. Wonderful. All right. So I just got one more page with a couple more of these. Again, I'm hoping this is easy. All right. I feel like it should be. All right. You're just looking at pictures. All right. So next example. Last page. I only got 2 more. Now I'm not doing, this is an odd numbered one, sorry, exercise 35. Now there's a reason I picked this one, because it has a scenario that we haven't seen yet, right? And that you don't see in 36. All right. So in 35, got this here. Now notice there are no arrows on this. It's a lot of clutter. But there's a solid point here, not an arrowhead. And you see this part of the graph here, the blue part. And then there's a solid point here, no arrowhead. All right, so solid point. Sorry, the cursor's on there now. Solid point on the far left here. Follow the blue. All right, another solid point. There's no arrow. And that's the point, -1,6, comma -6. Right, they're pointing these ends out. They're giving you the coordinates. All right, and then this red dashed line, the y-axis, right? I don't know why it's dashed. It's not being touched. All right, it's not being touched. That's not part of the graph. Usually dashed lines aren't part of graphs, right? And then this part up here is basically the same thing. You got a point, no arrowhead, right? Just a solid point, 1,6, comma 6. And then more points, more points, more points, more points, more points to this solid point here. No arrowhead, right? It's not continuing forever. It's stopping at the point 6, comma 1/6. Alright, so for the domain, you're looking at x values, right? And you're going left to right. The lowest x coordinate that is actually used is -6, right? There's a solid point there. They're telling us the x coordinate of that point is -6, right? And it looks like every x coordinate from -6 onward, as I move to the right, is used up until -1/6. All right, this point where this left piece ends has an x coordinate of -1/6. And then from -1/6 to +1/6, there's nothing. No graph, no points. So we have from -6 to -1/6, all right? And then we make a jump. We skip some. And then it starts up again at +1/6, right? An x value of +1/6. And then going down, there's all these points with x coordinates up to 6. So from -6 to -1/6, and then there's a gap. There's a jump in the domain. So we're going to use, you may recall in interval notation, you use the union symbol, right, to represent gaps, to represent holes and jumps, right? So -6 to -1/6, union, right, in union with, and then from +1/6 to +6. Those are the values of x in the domain. All right, so writing that out in interval notation would look like the following. So the domain for that, again, we have two intervals actually, right, because there's a gap, there's a jump. We have all the x values from -6 to -1/6, and there were points with an x value of -6 and an x value of -1/6, so those are included. I put brackets. And then there was a gap. There was a break, a jump, right? I put the union symbol. Now the union symbol is the set notation symbol for the word or. All right, so my x coordinates for this graph are either in this set or in this other set from +1/6 to +6, right? And there was a point with an x coordinate of +1/6. There was also a point with an x coordinate of +6, right? So brackets on those. And there's your interval notation for the domain. Now, if you were to write set builder notation for this, it'd be all values of x such that, and I need to do like inequalities for both of these, such that either x is between -6 and -1/6 including, or, right, that's what the union symbol represents, or this other interval, from 1/6 to +6 including. All right, so that's what it would have to look like if you were doing set builder notation. And then I'm pretty sure the range is the same, looking back at the picture. All right, again, we're looking at the y-axis, right, going from bottom up, and the lowest y value that starts being used is at -6. Right? They even tell us this point here has a y coordinate of -6. So -6 is in the range, and then all these points here on this bottom part of the graph have y coordinates from -6 up to -1/6. Right? They tell us this point here has a y coordinate of -1/6. So from -6 to -1/6, those are in the range, including those. And then there's a jump, right? There's a gap here where from -1/6 to +1/6 on the y-axis, there's nothing. No points. Big gap, big hole. And then we start up again at a y coordinate of 1/6, right? You see this point here has a y coordinate of 1/6. And then all the values of y from 1/6 up to 6 are also used. All right. And then nothing else, right? There's no arrows again. So it has the same range as well, right? The range, right, all the y coordinates that are used are from -6 to -1/6, including, right, then there was a gap, there was a break in the range in the y values being used, and then from 1/6 to 6, including those as well. And if you were to write this in set builder notation, it would look exactly the same as for the domain, only you'd be using, the variable y. because they are the y coordinates of the points on the graph. So -6 less than or equal to y less than or equal to -1/6, or, right, or for the union, where the union symbol represents. And then 1/6, less than or equal to y less than or equal to 6. It's the same thing, just with y, right, describing y coordinates. But all they wanted was this, right? All they wanted was the interval notations for the domain and range, even though, the set builder notation is equally valid. You could also just describe in words, if you wrote them out, what the domain and range are. And that would also be equally valid. And it's just that they were asking for interval notation here, so that's what I gave them. All right, and then the final example, 36, exercise 36 from the text. Right? All right, so here there's another arrowhead. So remember what that means. That means goes up forever. Now notice this is kind of tilting up and to the right. So going up to the right forever, right? So the x's will never end. There's no highest x coordinate because it's going to the right forever. And there's no highest y coordinate because it's going up forever. All right. Sorry, I keep forgetting to put the cursor on. So again, the arrowhead's going up to the right, very slightly, but it's still going up and to the right. So again, there's going to be no highest x coordinate because it's going to the right forever. And there's no highest y coordinate because it's going up forever. All right. So domain. All right, domain, remember you're looking at x values. You're looking from left to right on the x-axis and seeing what x values are used as x coordinates on the points of this graph. So going left to right, the first x value that has anything to do with this looks like just to the left of -2. Now they do tell you to estimate. I didn't read that earlier, but they do tell you to estimate, if it's not a nice integer. So I'll say like -2.2 or something, right? Just to give me a value less than -2. But you see the first x value that has anything to do with this graph is, say, at -2.2. Now notice that that is not the x coordinate of this missing, there's not a point here. It's one of those open points, empty points. So we're going from -2.2, let's say, again, just eyeball it yourself, whatever you want to say, as long as it's between -2 and 4. So say from -2.2, not including -2.2, right, open point, and then all the values to the right of -2.2 are the x coordinate of some point on this graph, right? 0's x coordinate there, 2 is an x coordinate here, 4, now I know you don't see it, but if you follow the arrow, eventually you'll get to a point with an x coordinate of 4. If you follow the arrow, eventually you'd get to a point with an x coordinate of 6, and 8, and 10, and a million. I mean, they might be crazy, crazy high up there, but you'll find them. You would get there. So from -2.2, again, I'm just saying -2.2, to infinity, right? Every one of those x values is used, except for -2.2, right? Because there's, again, the open point there. All right, so domain, and just eyeballing that first value, say -2.2-ish to infinity, right? There was no highest x value. Parentheses always on infinities, and as I said, right, there was an open point they showed us. So that point did not have -2 point whatever, -2.2 I said, as an x coordinate, so parentheses on that. And if I were doing, set builder notation, I'd say all values of x such that x was greater, just greater than -2.2, right? Or whatever you want to say, -2.1, -2.2, something a little less than -2. Right? Great. But not including. All right, and then for the range, going back to the picture, range, you're looking at the y coordinates, y values, right? Going bottom up. Now the lowest y value that has anything to do with this graph is -4, and look, there are solid points here. there are points on this graph with a y-coordinate of -4. And there are points on this graph with any of the y values above -4 as y-coordinates as well. Right? 2 is a y-coordinate for these 2 points. 4 is a y-coordinate for these 2 points. Now 10 is not the y-coordinate of this open point, right? That's missing. But, right, 10 is the y-coordinate for a point over here. If you follow the arrow, you would see a point. If you were to continue this, you would see a point with a y-coordinate of 10, of 12, of 14, and so on, and higher and higher and higher. There is no highest y-coordinate. So I put, infinity for the other end of the interval. So from -4 to infinity are the y values being used as y-coordinates, including -4. Right. So from -4 upward, -4 to infinity, bracket on -4, right? -4 was actually a y-coordinate for some points. And then always parentheses on infinity. And if you were to write this in set builder notation, I would say it's all values of y, such that y is greater than or equal to -4, right? -4 is actually included. But they don't need that. They just wanted us to estimate the interval notation for the set of the domain and the set range. Right? And that's it. There are other examples you can try, other exercises, but it's doing pretty much the same thing. Now, I didn't come across any with negative infinity. We've seen infinities when there's no highest x value being used or no highest y value. If there's no lowest x value, or if you're going to the left forever, then you'll have negative infinity involved in the domain. And if there's no lowest y value, or if you see an arrow going down forever, then you'll have negative infinity involved in the range. Right? Just understand that that's possible. And you would put parentheses on negative infinity as well, because negative infinity is, again, not a number. It's a concept, so it doesn't actually belong to the set. Put parentheses on it. Great. And I'm hoping that watching me go through these 8 examples here help you out in some way when you're asked to state the domain and range of a function from its graph on your own. And thank you very much for watching.